Yes, welcome to DC Economics. So coherently we are going to talk about the eigenvectors of a matrix. Eigenvectors is a vector that is associated with a set of linear equations. So the eigenvector of a matrix is also known as latent vector or proper vector or characteristics vector. So these are defined in the reference of a square matrix. Let's try to look at an example on what is known as 2x2 matrix. For example, find the eigenvectors of the following matrix A, that is containing some element that is 6, 4, 1, and 2. First, we need to find the eigenvalues of a matrix. We take out A minus lambda I, whereby lambda represents the eigenvalues of the given matrix, whereby I represent the identity matrix. So we given the matrix A, the matrix should be identical. So we take out 6 minus lambda, the right diagonal 2 minus lambda 1 and 4. We find the determinants. Second, we find the determinant and we equate is equal to 0. So this will give you now 6 minus lambda times the right diagonal, that is 2 minus lambda, then minus 1 times 4, that is equal to 4. So minus 4 we equate is equal to 0. Now take out 6 times 2, that is 12. Take again 6 times negative lambda, that is negative 6 lambda, minus take out negative lambda times 2, that is negative 2 lambda. Then take out negative lambda times negative lambda, that give you lambda square minus 4, which is equal to 0. Now take 12 minus 4, that is 8, minus negative 6 lambda minus 2 lambda give you negative 8 lambda plus lambda square. Now let's arrange the quadratic equation in a proper way. That will give you exactly lambda square plus lambda square minus 8 lambda plus 8, which is equal to 0. So let's use the calculator to solve the particular equation in an easier manner. So when you try to solve this particular quadratic equation, will give you exactly lambda 1, that is equal to 6.828 427,125, and lambda 2, that is equal to 1.1715. So since we have the lambda 1 and lambda 2, now those are referred to as eigenvalues of a given matrix. Now it is possible now to solve the eigenvectors. Now let's find the eigenvectors on this kind of matrix. Since we have solved already the eigenvalues of a matrix, now we find the eigenvectors by taking the lambda minus A minus lambda I. We multiply the unknown values, that is lambda 1 and lambda 2, that is x and y, we equate is equal to 0. Now after taking that, now we equate out 6 minus lambda 1, then 4, then 2 minus lambda, and we multiply by x and y, we equate is equal to 0. So lambda 1 is 6.828427125. So let's plug in the lambda 1 to the equation. So this means that we'll be having 6 minus lambda 1, that is 6.828427125. So we plug in the given equation. So when you plug in lambda 1 to the equation, so this will give you now 6 minus 6.828427125, 1. Then again we take out 2 minus 6.828427125. Now we solve the particular equation. So this means that we'll be having negative 0.82842712 and 1. We have also 4, negative 4.82842712. We multiply the unknown values x and y, we equate is equal to 0. So what we're going to do here now, let's multiply the given laws on the matrix with column. That is the unknown values x and y. So when you multiply laws and columns together, this means that we take out negative 0.82842712 times x. That will give you negative 0.82842712 x plus, you take out 4 times y, that is 4y, we equate is equal to 0. Again, we take 1 times x, that will give you x, then plus, we take out negative 4.82842712 times y, that will give you 4.82842712 y, which is equal to 0. Now let's solve the given equation 1 on this kind of simultaneous equation. So we take out the equation 1, that is negative 0.82842712x plus 4y, which is equal to 0. Let's make x the subject. Negative 8.0.82842712x is equal to, take out 4y to the right hand side, that will be minus 0. Minus 4y. Negative 0.82842715x is equal to negative 4y. Let you divide by negative 0.82427125 both sides of the equation. So the left number will be cancelled out to become x is equal to, take out 4 divided by negative 0.82842725, that is positive. The answer will be equals to 4.82842712 y. Now after taking that, in order we can obtain the eigenvectors, let you divide again by 4.82842712 both sides of the equation. So remain with x, that is 1 over 4, that is x over 4.82842712, and remaining with y, which is equal to 4.82842712. Remaining with 1, so it will be y over 1. So the ratio of x over y is given by taking x is equal to y, that is equal to 4.822712 over 1. So the eigenvalues of the matrix, so the eigenvectors of a matrix is equal to 4.82842712, 1. So remember, the eigenvectors that we have found this time is for lambda 1. When lambda 1 is equal to, it's when lambda 1 is when lambda 1 is equal to, is when the lambda 1 is equal to 6.82842712. Let's go quickly and find the eigenvectors when lambda 2 is equal to 1.17157287. So the eigenvectors is given by taking the determinant, that is a minus lambda I times unknown values of 0. So when you try to equate the equation, this means that we'll be having the same as we did on the previous equation. So we'll be having 6 minus lambda 1, 4, 2 times lambda times unknown values x and y, which is equal to 0. After taking that, let you plug in lambda 2, that is 1.1715728 to the equation. So 6 minus lambda 1, that is 1.171572875. 1, then divide by 2 minus 1.712722875, then times the known values x and y, which is equal to 0. So after minus 6 minus 1.712722875, so when you minus, remain with 4.828424, 4.82842725, then 4, then 1. Then when you minus 2 minus 1.7572875, remain with 0.82427125. Then times the known values, x and y, is equal to 0. We do the same as we did on the previous eigenvector. We multiply rows into the columns. So 4.82842725 times x, this will give you the same 4.82842725x, then plus, take out 4 times y, that is 4y, so is equal to 0. So again we did 1 times x is x plus 0.822725y. This means that we check out the value of 0.824 and etc times y, that give you 0.82427125y, which is equal to 0. Now let's work on equation number 1, that is 4.82842725x plus 4y, which is equal to 0. Let's make x is a subject to the equation. So x, when you make out x is subject, you need to divide by 4.82842725, both sides of the equation. So it will be 4.82842715, x is equal to negative 4y. So let's divide by 4.82842715 both sides of the equation. Remaining with x is equal to negative 4y divided by 4.827125 is equal to negative 0.8287422724y. So after remaining with that, let you divide by negative 0.8284272724 both sides of the equation again, in order to obtain the ratio of the given eigenvectors. So remaining with now x over negative 0.82842724 is equal to y over 1. So this means that the ratio of x over given y is equal to negative 0.82842724 over 1. So this means that the eigenvectors of a matrix and are given the eigenvectors of a matrix and are given lambda 1 and are given the value of lambda 2 is equal to 0.2284271245 is equal to 0.828427.24, 1 is equal to 0.8284272124, 1. Also the given values of the eigenvectors when lambda 1 is equal to 6.82842725 is equal to 4.8828427123, 1. So that is the answer for the given eigenvectors of a matrix and are given eigenvalues 1 and 2. Let's try to look another example, the last example on how we can solve the eigenvectors of a matrix. Find the eigenvectors of a matrix that is 2, 4, negative 1, 3. First of all, we find the eigenvalues. So remember that the eigenvectors is found from the eigenvalue after obtaining the eigenvalues of a matrix. So we take A minus lambda I represent our identity matrix, and lambda represent the eigenvalues. So 2 minus lambda, 3 minus lambda, negative 1 and 4 to the right diagonals. We find the determinant and equate is equal to 0. So 2 minus lambda 4, negative 1, 3 minus lambda is equal to 0, times 2 minus lambda times 3 minus lambda minus negative 1 times 4 is 4. So we equate that is equal to 0. So let's you take the equations and work out on the equations on the given values. So it will be 6 minus 2 lambda minus 3 lambda plus lambda square plus 4, which is equal to 0. So when we times the equations, lambda square minus 5y plus 10 is equal to 0. So lambda 1 is equal to 2.5 and lambda 2 is equal to 2.5. So after obtaining the given eigenvalues of the matrix, let's find the eigenvalues. Let's find the eigenvectors of the matrix by plugging lambda 1 and lambda 2 to the equation. So for the given lambda 1, that is 2.5, A minus lambda I times the known values x and y is equal to 0, 0. So this means that it will be now 2 minus lambda 4, negative 1, 3 minus lambda times the known value x and y is equal to 0. We plug in lambda 1 to the equation. That will be 2 minus 2.5 for negative 1, then 3 minus 2.5 xy times the known values x and y is equal to 0. So 2 minus 2.5 will give you exactly negative 0.5x. So this means that it will be negative, the matrix will be negative 0.5, then negative 1, then 4, then 0.5 times the known values x and y is equal to 0. Now let's multiply columns, let's multiply rows into columns. So it will be negative 0.5 times x is equal to negative 0.5x plus negative 1 times y is equal to negative y, which is equal to 0. Then again we take out 4 times x, that is 4x, plus 0.5 times y is 0.5y. So 0.5 times y is 0.5y is equal to 0. Let's work on the first equation. So it will be now negative 0.5 x minus y is equal to 0. So it will be better now we make out the subject from the, we make x is a subject to the given first equation. So it will be negative 0.5x is equal to y. Let's divide by negative 0.5 both sides of the equation. So it will be x is equal to y divided by negative 0.5. So take 1 divided by negative 0.5 give you negative 2. So x is equal to 2, negative 2y. Now divide by 2 both sides of the equation to obtain the ratio of the eigenvectors. The ratio will be now, the ratio of x over y is equal to negative 2, 1. So those are the eigenvectors of the given matrix. So since x is equal to y, so the ratio of x given y is equal to negative 2, 1. So we may conclude now the eigenvectors of a matrix when lambda 1 is equal to 2.5 is equal to negative 2, 1. Now since we are required again to solve the eigenvectors of the second matrix of the same matrix when lambda 2 is 2.5, the answer will be the same, since lambda the given eigenvalues are the same. So lambda 3 will be equals to 2.5. The same applies to lambda 1. So thank you, welcome to DC Economics. Don't forget to subscribe and watch on other videos. Bye bye.